Hello, my name is Adam McCormack,
My name is Mitchell Pavao.
and this is our ECE 2001 Circuits Project 2 demonstration video.
Cool. Alright, so this is our circuit. It requires the whole board, and we'll go into details about it.
So for our circuit, we use two types of amplifiers, a non-inverting, which is shown above, which has a gain of 1 plus the feedback resistor over the other resistor. And then the second amplifier that we used was an inverting amplifier, which has a gain of the negative resistor feedback divided by the other resistor. And these two resistors both have their pros and cons, which is why we use both in our circuit. So the microphone, which is shown right here, is powered by a DC current, and it creates an AC current when sound is played. So we use a capacitor and resistor in series with the microphone to block any DC current. So the first thing that we did was we measured the output voltage of the microphone, which we found to be 40 millivolts when the phone was 4 inches away from the microphone. And this made us come to the conclusion that we wanted to have around a gain of 10 for the microphone to get the output to around 400 millivolts, which was what we measured for the auxiliary. To get this, we used a non-inverting amplifier, which was previously shown, which, to recall, has a gain of 1 plus the feedback resistor divided by the other resistor. And we did this by using a 1 kilo ohm as R1 and the potentiometer acting as a 10 kilo ohm as the feedback resistor to obtain the gain of around 10.
And then after that, the next part of our circuit was the auxiliary. So we found out, as Adam said, that the auxiliary input was around 400 millivolts. So we felt we did not need to amplify it. So there's a 10K pot there that is for the control, just as there was one in the microphone amplifier. So then it gets run to the summing amplifier. The summing amplifier sums the auxiliary and the microphone input. So here we thought, when they were coming in, the amplitudes were at 400 millivolts. We thought that was a sufficient value, so we didn't feel the need to amplify. So we used an inverting amplifier with a unity gain of 1. So they would not be gained. So they're 20K ohm resistors all the way around. And then that gets coupled through another capacitor. This one was 470. The values weren't specific. And then that goes to the laser circuit.
So the laser needs to be supplied by a DC supply voltage to be able to transmit the signal. So the output comes from the summing amplifier and then gets run through a capacitor to filter out the DC current. The 9-volt power source got fed through the inductor shown here to block the AC current. And this was to ensure that no AC current was going through the laser. And then we used a 100 ohm resistor to make sure that we didn't blow out the laser.
Alright, so then after the signal gets transmitted, it gets picked up by the receiver circuit. So the receiver circuit starts with the photodiode, which takes the signal from the laser. So then that gets coupled through a 10 microfarad capacitor to block the DC current, and then it goes straight into another inverting amplifier. So here there wasn't a specific gain that we desired like the previous stage, but just for the purpose we wanted a gain of 5. So using the equation minus RF over R1, RF being the 11K ohm and R1 being the 28K ohm, it gives it about a gain of 5, a little bit more than 5. So then that gets coupled through another 10 microfarad capacitor, and then once again to block the DC current, and then that goes straight to the 8 ohm speaker.
So now we'll present how our circuit works.
So ours works off 9 volts, positive and negative. All of the amplifiers do. So we used 2 9-volt batteries to acquire that. So when just going on YouTube and playing a 1 kilohertz signal, it's just will stay at 1 kilohertz. And then this is the laser right here from the transmitter circuit, and this is the photodiode right here. So when initiated, it should play the 1 kilohertz signal outside of the thing. And it's on right now, so if I take it away, so it is on right now, but it's not in the photodiode, and then when I apply it, it does work. Alright. And then after the batteries are taken apart, that's it.
So one thing that we would do differently in the next time would be to add a low pass filter to the receiving circuit, just to make sure there's no background sound coming through the circuit and the speaker. So this would make our sound coming through the speaker a lot clearer.
Yes. So, and then another thing that we would like to do would be to, instead of using 2 9-volt batteries, to use 1 9-volt battery. But that would also change the input or the supply voltages of the amplifiers to 4.5 volts instead of 9. So those are 2 things that we felt we could have done better about our circuit.
So that's about it. Hope you liked our video.
Thank you.